In this video segment, we're going to be talking about two things that are related to each other. One of them is called a ratio, and the other one is called proportions. Now, proportion is actually two ratios made equal to each other. We'll be using those in different formats within some of the typical SAT problems that you'll be covering. So let's take a look at some examples. Okay, we're going to look at ratios first. If you've already looked in the Princeton Review booklet and you've studied a little bit about ratios, you know that what they recommend using is something called a ratio box. And it's pretty good, although you can do a lot of ratio problems in your head. The ratio box is a way to do it so that it's almost foolproof. Let me show you the basics of it. I'm not very good at drawing rectangles here, but bear with me. Functionally, whatever I draw will work. Now, in a ratio, you're comparing two things. So in the top here, on this top row, this down here will be your labels. And then your two things you're comparing, let's say it's boys here, girls here. And then this last column they call whole. And then here they're going to actually put what the ratio is. I'll put an R here for ratio. And this middle, they're going to put the multiplier. I'll put a time sign there. And the bottom's going to be your total of everything. So let's say we had a 3-to-2 ratio of boys to girls in the senior class at some hypothetical school. So we put in that ratio 3-to-2. And let's say in that senior class there's 250 students. And let's say the question's asking how many of those 250 students were girls based on this information. What you do is you add up the two ratio numbers and you put that number over here, and then you take that number and divide it into the total number of people. So 5 goes into 25 5 times, and 0 times. So our multiplier is 50. You use that same multiplier all the way across. That way, when you take the 3 times the 50, you know that there's 150 boys, and you know that there's 100 girls, and that's what you're trying to find out. Okay, let's take a look now at a typical problem. And I say it's typical because in this problem, we have a mixture. And you'll find that the ratio problems in the SAT, a lot of them are typically mixtures. And they give you a ratio, and you have to figure out something about that mixture. In this case, we've got a bakery, and they're making some flour, and it contains corn, wheat, and rye in the ratio of 3:5:2. And if a bag of the mixture contains 5 pounds of rye, how many pounds of wheat does it contain? Now, unlike the introductory ratio problem that I gave you when I was introducing the ratio box, there I had given you a total of the whole thing. I gave you the total of number of students in a senior class. And here they're giving you the total right here, 5 pounds, of only one of the items. So they've thrown you a little bit of a curve there. The other curve they've thrown at you is that you've got 3 ratios. You've got 3 ingredients instead of just 2. So the question is, does the box method still work? And the answer is yes. Let's do this together. We, of course, start with our box. And in this column here, we're going to have the same things we had before. We're going to have our ratio here. I'll just put RAT since we don't have much room. And the next one is going to be your multiplier. I'll put a time sign. And the bottom one is our overall totals. Our 3 ingredients are, we've got corn, We've got wheat, and we've got rye, and this is going to be the whole of all this. Like I say, we don't know how much total flour we're making here. What they did tell you is that you have a total down here of 5 pounds of rye. We know our ratios. It's 3, 5, and 2. Now, as before, we add the 3 to the 5, we get 8, and 2 is 10. And now, with that information, we've used everything we've got up there. We have to figure out how many pounds of wheat. This right here is what we need to figure out. So can you do it? Well, you know that the multiplier row here, that it's going to be the same all the way across. So what you look at now is, how did we get this 5? What multiplied times 2 gives you 5? Well, you can do that in your head, or you can do it on a calculator. 2 goes into 5, 2.5 times. And like I say, you would use that same multiplier all the way across. And we're only interested in this right here, the wheat. So you would take 2.5 times 5, and you'd get 12.5. And that would be answer E. Okay, we have another ratio problem here. There are 250 students in the 10th grade at Northgate High School. All the 10th graders must take French or Spanish, but not both. If the ratio of the males to the females in the 10th grade is 2 to 3, and 80 of the 100 French students are male, how many female students take Spanish? Well, to solve this, we're going to use the same methodology we used on the last problem, and that is we're going to use a ratio box. And this time we do know that there's 250 students total, and what I want to do first is I want to figure out how many of that 250 are males and how many are females. So we'll do that part first. So let's draw our box. Draw it over here. And this is very similar to the example I gave you in the beginning of when we were speaking about using this tool. So it should be pretty simple for us. Okay, this is our overall totals. This is our multiplier. This is our ratio. And we've got boys and we've got girls. And this is the whole. Okay, let me draw these lines down. All right. So the ratio of males to females is 2 to 3, so we put a 2 here, a 3 here, and it's a total of 5. And there are 250 students overall. So we have to figure out how many of those are boys, how many are girls. This is just like what I did earlier. And that is, you take the 5 into the 250 and you get 50. 5 times 50 is 250. And we put that all the way across. That means there are 100 boys and there are 150 girls. Now, this other thing that we're going to do, it's not really a ratio box, but it is a box. We're just going to organize our information now and see how we use this. Now, on the top, we've got boys and girls still. And down here, let's put Spanish here. I'll put SP for Spanish, and we got French. I'll put FR. And the we'll put another box down here for some totals. Okay. All right. So, what do we know from the rest of this problem? They say that there's 80 of the 100 French students. So in French, we've got, this is our French, and we've got a total of 100 French students, okay? So we'll put 100 here. And we've got, in Spanish, we don't know what we've got exactly there yet, but we've got 80 boys in this French class. So we've got 80 boys, and that means that if there are 80 boys in that French class, there has to be 20 girls. So we'll put a 20 here. Now, we know our totals of boys and girls. We know the total down here has to be, for the girls, is 150. And we know that the total for the boys has to be 100. That means if this is true, we know that there has to be another 20 for Spanish up here, and there has to be another 130 girls for Spanish up there. And the question was, how many female students take Spanish? And we found that out already. There's 130. And so this was a grid in, so you would do that. You would just put in 130 in the grid in. Okay, let's take a look at yet another ratio problem. A science class has a ratio of girls to boys of 4:3. If the class has a total of 35 students, how many more girls are there than boys? Now there's a little bit of a Joe Boggs here in that they're asking you how many more girls than boys. And if you don't read this real carefully, somebody may just think, oh, I just need to figure out how many of these are girls. And you'd think it was like that introductory problem I gave you. But that's not really, we can't stop there. We want to know how many girls, how many boys, but then we have to do some subtraction. So let's go ahead and do the first part of it, which is pretty simple, because we've been doing some things that are very, very similar already. And we'll draw our box, and we'll put in our usual rows here. This is going to be your multiplier. It's going to be your ratio. This is going to be the total number. And we've got, again, boys and girls. And we've got, well, it's boys and girls. And you got to make sure when you do these ratios, you get them in the right order. It doesn't matter. It'll be a 4 here and a 3 over here. And this is our whole. And like before, you'll add those together and you'll get a 7 here. And our total is, where is that? 35 students down here. Now, 7 goes into 35 5 times, so we put a 5 all the way across. And then we can see how many boys. We've got 15 boys, and we've got 20 girls. Now again, be careful here because you have to know how many more girls than boys. And you can see here that if you subtract 15 from 20, there are 5 more girls. And so your answer would be D.